Hello everyone, welcome to this video on the fourth lesson of the sound and light scheme. This one is about longitudinal and transverse waves. And just like in the second lesson, what is a wave, my main recommendation for this lesson would be show students lots and lots of examples of different waves and get them to look at what's happening using these two concepts that we're introducing here, longitudinal and transverse waves. Because what I see so often when this is being taught, and I think this is because people maybe don't feel confident in the subject knowledge, so like, oh my god, I've just got to make sure students get these definitions somewhere in their books. But what happens is, you know, the first moment of the exposition, it's like, right, boom, here's two bold definitions: longitudinal waves, oscillations parallel to the direction of energy transfer, transverse, vice versa, without students having any concept of what's actually being talked about. So I would say, rather than starting with the abstract and then, you know, go into the concrete, as I'm sure we all know by now, start with the concrete and then we'll pull these abstract definitions out once we've had a look at a few examples. So the first one I would do is to go back to what I had in the last lesson, which is a tuning fork, because it's really simple. If you have a speaker, some sort of loudspeaker handy, and you can show the speaker cone going back and forth like this, that's also a good way of doing it. But the tuning fork is super simple. So what I want to do is I just want to remind students of how it is that the tuning fork makes a sound. This is something that was covered in the last lesson, so I'm going to whack it on my desk. That is a technical term. And I'm going to show them that this thing is oscillating, and they can see that because it's kind of blurry. And then I'm going to show this on a diagram as follows. So I'm going to sketch my tuning fork again, something like that. And I'm not going to go into all the particle diagrams this time because I did that in the previous lesson. I don't want to waste loads of time going over it again. But what I hope they've seen from my very rudimentary demo is, how does the tuning fork oscillate? Well, it oscillates by the arms of the tuning fork, or the prongs, going back and forth like this. And then I won't go into loads of detail here, but I'll just remind students that what's happening here is, first, this oscillation, this disturbance, the oscillation of the tuning forks disturbs the air, so you get some oscillation in the air over here, and this disturbance spreads throughout the medium, which in this case is air, and it goes like this. So this oscillation spreads throughout the medium. So these air particles bump into one each other, then these air particles, then these air particles, and so on. And again, as I said in the previous lesson, this is where some sort of video animation might be good. But the point that you want to make is that when you whack the tuning fork and it starts oscillating, this oscillation spreads through the medium. So I might put through air, and I'll remind students that in this case air is the medium through which that disturbance is spreading. So what I'm going to do then is contrast that to water waves, and I've put a little the kind of question on the title slide of the slides that are available on Google Drive. What's the difference between sound waves and water waves? And here I might use the ripple tank again. So maybe get the ripple tank out, and you could show what's happening here as follows. So if this is your this is the ripple tank here, and you've got that kind of thing that's I don't know what you call that, the bar that goes across the ripple tank. What happens here is this moves up and down. So you've got an oscillation here, and that causes this part of the water to move up and down. So if I do it like this part of the water moves up and down. Well, and likewise, this part of the water then starts to move up and down, and this part of the water, and this part of the water. It's easier when you're illustrating longitudinal versus transverse maybe to just do it once. So rather than a continuous oscillation, just do a pulse. So just move down once, and you can see that downward pulse spreading through the medium. But what you want them to notice is, well, yeah, I can see the water's kind of moving up and down, so but the oscillation is spreading this way. So I might put here oscillation spreads through the medium, which in this case is water. Now you, as physics or science teachers, I'm sure have already spotted, there's something different here. But it's worth questioning students and really taking your time to make that clear. What exactly is different here? Well, it's the fact that the oscillation in both cases is spread in the same way. The sound wave travels through the air that way towards the person's ear, which is maybe over here. In the ripple tank, the oscillation spreads, and you can see, you drop the pebble in the water and the ripple spreads that way. But look, what's different here is the direction of our oscillations. And this is the first introduction we can give to what we're talking about, which is longitudinal and transverse waves. But you might not even want to put those words on yet. You might want to then get a slinky spring and say, okay, let's think about this a different way. And again, a pulse here is really good. I don't have a slinky spring to hand, but a pulse here is really good rather than a continuous oscillation. And you might get you at the front and then a student holding the other end of the slinky spring. And you might say, okay, what's one way I could transfer energy? And they'll show you, how you could move your hand. And what you want to do, and you could map this so that the longitudinal stay at the top and the transverse stay at the bottom. But you can demonstrate this, but we're just going to sketch it now, is that one thing you can do is make an oscillation go like this. And again, a pulse is easier. If you move your hand back and forth like this, well, what you get is this kind of compression area. Again, we don't need to go into those words at this stage, but a compression area here, and that's going to spread. So a few seconds later, that's going to be over here. A few seconds later, that's going to be over here. A few seconds later, that's going to be over here, and so on. And each of these is illustrating that we've got some sort of oscillation spreading throughout the medium. And what's the medium? In this case, it's not air, it's the slinky spring. And again, just to really drive the point home, I'm going to say, and again, this is why a demo is really good, because you can see this. It's a lot easier to see it in a real demo than it is in a visualizer diagram. But I'm going to put oscillation spreads through slinky, through the spring. I'll put through spring. Contrast that with the other way that you can get an oscillation from you at one end of the slinky to the student at the other end. You could go like this. So you could move your hand up and down, and then what you get, and maybe it's easier if I actually draw the pulse here. It would be easier to illustrate, is that pulse then moves down. Sorry, that's not very well drawn, is it? Because that should be upwards like this. So if you move your hand up, again, this is easier to demo than it is to draw, really. But that pulse spreads through. So if you move your hand up like this, that pulse spreads through the medium. So again, you could label this as oscillation. I'll just do this shorthand. Oscillation spreads through spring. So all of these are illustrating the difference between longitudinal and transverse waves, because what you want them to notice is here, this part is moving up and down, or maybe just up. Now that part is moving over here. So where that oscillation is happening, it started off on the left, and now it's moved over here. Maybe I'll do that just for consistency's sake. So what you can then do, once you've gone through some concrete examples, and again, if you can find more examples, that's even better. Maybe you want to do a guitar string is a bit more complicated because it's horizontal. Maybe it's easier if you get a double bass or a harp or something like that, where you've got a vertical string and you can literally ping it one way and watch it move in that way and watch the sound go that way. Like I say, a speaker cone would be really good for longitudinal wave. All sorts of sound waves you can do. And then in terms of transverse waves, it's a little bit more tricky, but ropes and water are a pretty good way of doing it. But the point you want to make is that in this case, in these two cases, the oscillations are going that way, but the oscillations are spreading that way, but the direction of oscillation is up and down that way. Whereas in this case, this is going back and forth, but the oscillations are still spreading in the same way. And you could give a definition, or you could just tell students verbally, because they're going to be writing down a definition later. But the main thing is that you want to say these two are examples of longitudinal waves. And if you've done a good diagram and explained it, longitudinal, sorry, that is a word I can't spell without thinking about it. These two are longitudinal waves. If you've done really good diagrams and you've explained it really, really clearly, that should be enough that students can come up with a definition and think for themselves about the definition rather than you just copying it down off your slide or whatever. And likewise, these two are transverse. And again, I would probably tell them verbally the difference between these is that transverse waves, they transfer energy that way, but the oscillations are at a right angle to that. They are perpendicular, we might say, whereas in this case, the oscillations spread that way, and but the oscillations themselves are back and forth. They're parallel to that. They're in the kind of same direction. And that should be enough to get students thinking about those definitions, and then later on in this lesson, you'll be asking them to turn those turn these diagrams into definitions themselves, and then all you want them to be able to do is to look at lots of different concrete examples and use this concept of longitudinal versus transverse to identify which is which. So you're shaping their experience of the world through the concepts that you've introduced, rather than give them a bald definition and ask them to copy it down, which doesn't really get them thinking in this kind of physical, scientific way. Okay, next lesson we'll do a little bit more on sound waves.